So the last lesson in this unit is on infinite geometric series. This is from your worksheet 12.4, infinite geometric series. So let's take a look. So an infinite geometric series has no end. We're adding up all terms, and it's an infinite series, so there are an infinite amount of terms. So when we talk about that, it says find the sum of the infinite geometric series if they exist. The only time that a sum would exist is if the ratio that we have is when the ratio that we have, the absolute value of that ratio, is less than 1. So what we really want is we want a fraction that's between 0 and 1. It could be positive or negative because we're saying the absolute value, but we want that absolute value to be less than 1. So let's take a look here. It says find the sums of the infinite geometric series if they exist. So the very first thing we need to do is identify what our ratio is. What am I multiplying by 1 to get 1/3? Well, I'm multiplying by 1/3. And I also multiply by 1/3 to get from 1/3 to 1/9, as well as from 1/9 to 1/27. So my ratio here is 1/3. 1/3, the absolute value of 1/3 is less than 1. So we do have an infinite geometric series that we can add. So the sum exists. Then the next thing I would do is identify what's my first term. Well, my first term is 1. So now I can go ahead and plug this into my sum formula. The sum of this infinite geometric series is 1 divided by 1 minus 1/3. So doing this out, I really could do this in my head, 1 over 2/3. And then I would multiply by the reciprocal of that. When I divide by 2/3, it's the same as multiplying by 3/2. And 1 times 3/2 is just that, 3/2. Or you could write that as 1.5. So the sum, as you add all of these together, goes to 1.5. The next problem says, find the sum of the infinite geometric series by using sigma notation now. So again, I need to find out, okay, what's my r? And in this one, it's actually a little bit easier. My r is easy to find because it's always the base of my exponent. So my r here is 3/2. Okay, so let's check here. 3/2, remember, we could write as 1.5. And the absolute value of 1.5, that's greater than 1. So here, this sum does not exist. If I did need to find the sum, I would go ahead and find the first term by plugging in 1 for I and calculating what the first term would be. If you have any questions, please see me or Mr. Daniels, and as always, have fun doing your homework.